So the first thing that we did on our Rube Goldberg machine was constant acceleration. And so what we did was we built a 1.09 meter wooden ramp, and that ramp had an angle of elevation of 2.67 degrees. And so basically it's just a ramp, and the marble rolls down. And the way we collected data on it is we did 5 equidistant intervals, and so we timed it, the amount of time it took to go in each of an interval, which is 0.2 meters. And so we did the first interval, we did 5 trials for each interval, so we did 5 trials for 0.2 meters, 5 trials for 0.4 meters, and so on until we got to 1 meter. And so the independent variable would be distance traveled in meters, and the dependent variable would be time. And so if we look at our graphs for constant acceleration, we can see that our x versus t graph, our position versus time graph, is a power function, and then our velocity versus time graph is it's a linear function. And so basically what our velocity versus time graph says, it says that for every second that the ball travels, it increases its velocity by 0.0131 meters per second. And so that's our velocity versus time graph. We took these from the averages, and then we all know velocity equals distance traveled over time. That's how we got those points. And then the acceleration versus time graph. So we were trying to get constant acceleration in this model, but the reason that our acceleration isn't flat and it's downsloping is because there's friction and air resistance. So that's why it's downsloping and not completely flat. But it does level out a lot, and it's really close to being flat. So that's what our acceleration is.